Grace and Noble.
Okay, gentlemen, let's talk about chromatic aberration. What is chromatic aberration? Just have a look at the pictures. When somebody is wearing a polycarbonate lens, for example, there will be some kind of color fringing. Remember this word, color fringing. It's a common occurrence when a lens is either unable to bring all the wavelengths of the color to the same focal plane. This is physics. All lenses have refraction, right? So when the light rays refract and come to a common focal point, some of the wavelengths of the colors might not be coming, and then what happens is there will be color fringing. This will be very well explained when you look at the picture, where you will see some kind of bleeding of color at the periphery of the picture. So chromatic aberration is caused by lens dispersion with different colors of light traveling at different speeds while passing through a lens. Again, I repeat, chromatic aberration is caused by lens dispersing with different colors of the light traveling at different speeds while passing through a lens. As a result, the image can look blurred and noticeable color edges like red, green, blue, yellow, purple, orange can appear around the objects. Okay, if you want to explain this to a patient or a customer, all you need to do is print out from the Google images chromatic aberration and show, like, if you are going to use this lens, see there is no color bleeding here, no color fringing here. And if you are going to use a polycarbonate lens, then you are going to have this kind of an issue if you want to explain it. But again, it depends on, don't be proactively trying to sell this unless you have a much better product which says this material is better than the other material, because as a salesperson you have to sell always the benefits first. If the customer is going to come and ask you what will also happen, then you can try to give them some kind of an update. Why does this happen? Because lenses have a Bay value. And what is a Bay value? It is a number given to describe the amount of chromatic aberration of an ophthalmic material. From the list on the side, you will be able to notice that the glass lenses seem to provide the best focus. So the higher the Abbe value, the less the amount of aberration. The lower the Abbe value, the higher the chromatic aberration. So in this list you will have crown glass having 59 as Abbe value, whereas polycarbonate has 30 as Abbe value. So there is more clear vision, less chromatic aberration in crown glass, as against polycarbonate it is higher, or rather the highest as per the list. The rest of the materials, CR39, mid index, high index, Trivex, they all have chromatic aberrations. But talking about the highest chromatic aberration, we can start with polycarbonate and then with Trivex, then with 1.6 is high index material, so on and so forth. A normal plastic 1.49 high index plastic CR39 material will have 58 Abbe value, which is closer to crown glass, which has 59. So amazing. Most patients will be very comfortable with the color here. All right. So this is what it is when it comes to chromatic aberration and Abbe value. Is that clear? If you have any questions, let me know.